your life work.
If a lump of calcium carbide is dropped into water, bubbles of gas will rise. If this gas is ignited with a match, it will burn. The gas is acetylene, and when mixed with oxygen in the proper proportion, it produces the intensely hot blue oxy-acetylene flame used in welding. The equipment necessary for oxy-acetylene welding consists of a cylinder of oxygen, an oxygen regulator, a cylinder of acetylene, an acetylene regulator, lengths of oxygen and acetylene hose, and a welding torch. Mounted on a hand truck, such an outfit is readily portable and can be taken to the work no matter where it may be located. For large-scale welding operations, the equipment is somewhat more elaborate. Oxygen and acetylene may be piped throughout the shop or plant from a central point. In all welding, suitable clothing must be worn to protect the welder. For oxy-acetylene welding, goggles must be used with lenses of special colored optical glass which protect the eyes from the bright flame and the intense glare of the molten metal. The welding torch mixes the oxygen and acetylene together in correct proportions. Separate valves regulate the volume of oxygen and acetylene. In lighting the torch, the acetylene valve is first opened slightly, and a friction lighter which strikes a spark is used. The oxygen valve is then opened, and the mixture of oxygen and acetylene adjusted. Because the temperature of the flame can be varied to suit the type of work, the oxy-acetylene welding process is a very valuable one. The pieces of metal to be welded together must be prepared properly so they are free of any foreign matter. They are held in position with due allowance for shrinkage. When the flame is passed over the edges, the metal is quickly heated to a plastic stage. The welding operator uses a welding rod of metal similar to that being welded. The metal from the rod is melted into the joint, thus fusing the parts into one solid piece. The easiest welding position is where the work can be laid out flat. However, when overhead or vertical welds are made, the temperature of the metal must be controlled very carefully, for if it is too high, the weld may sag or drop out. The first-class welding operator must be able to weld work in any position, and he must be able to weld all materials. Many various metals can be welded, and welding is not only a trade in itself, but a part of nearly all occupations in which metal is used, including sheet metal work, boiler making, and steam fitting. The welder often uses oxy-acetylene flame for cutting iron and steel, employing a cutting torch. This is similar to the regular torch, but it has an extra valve, operated by the thumb or finger, which controls a stream of pure oxygen. The metal is brought to a red heat at the point where the cut is to start. The cutting oxygen valve is then opened. The stream of pure oxygen combines chemically with the hot metal and burns it away along whatever pattern the torch follows. This process may be used to cut very thick metal and may also be used to cut metal underwater. Spot welding is one example of the type of electric welding known as resistance welding. One of its important uses is that of joining sheet metal together. The spot welder is a machine with two copper electrodes. The sheet metal to be welded is placed between the points of the electrodes and the current is turned on. The resistance of the sheet metal to the electric current, which passes between the electrodes, causes it to heat quickly to the fusion point, and pressure on the electrodes squeezes the metal together. Other types of resistance welding are similar in nature. In arc welding, the material to be welded is grounded to the generator, either directly or through a metal table on which the work is placed. The electric current is transmitted to the rod holder through a heavy cable. Touching the rod to the work completes the circuit and causes a spark, or arc. The intense heat of the arc melts both the metal and the welding rod, causing them to fuse together. In shielded arc welding, the welding rod is coated with a special substance which forms a gas. The gas shields the molten metal from the oxygen and nitrogen in the atmosphere, thus preventing impurities from forming. A weld of high quality is the result. When it is unnecessary to add metal to the joint, only the metal being welded is melted, and a carbon rod or electrode which does not melt is used. The mask worn by electric welding operators protects the face as well as the eyes. The electric arc gives off ultraviolet rays, so there must be no bare skin exposed, and clothing must be worn which will protect the operator from burns. Proper ventilation is necessary for all indoor welding. In production work, the welding operator may work on only one kind of material, held in a jig or form, and with just one kind of welding equipment. The operator may become highly proficient in specialized work and still not qualify as a skilled welder in other types of work. Job welding calls for a greater variety of skills. One time the welder may use the oxy-acetylene flame, and another time the electric arc. One job might be welding cast iron, and the next mild steel, and still another a different kind of steel or alloy. The job welder must therefore understand how to work with many materials in order to adjust his equipment correctly and select the right welding rod for each one. If you plan to be a welder, to be successful you must have good eyesight, fine muscular coordination, and because much of the work is strenuous, you should be strong. In addition, a good knowledge of welding principles is necessary, along with practical blueprint reading and some mathematics. Electrical physics and some chemistry will be helpful. Many schools offer elementary shop courses in welding, both during the day and at night. There are many private welding schools. If you decide to attend one of them, investigate thoroughly and select a good one. Many machine parts which used to be cast as one piece are now welded from steel plates. This process provides greater strength with less weight and at lower cost. In the automotive industry, welding is employed in many ways. It has made possible strong steel automobile bodies, as well as the coaches and engine cabs of streamlined trains, lightweight and attractive in appearance. The stout tubular frameworks of airplanes are welded, as are countless other parts, from fuel tanks to landing gears. Such welding is carefully inspected, and if you choose welding as your life work, it will be worth your while to work hard to qualify yourself as an inspector. There are many welding jobs in shipyards. Large hull sections can be welded together in shops, then hauled and hoisted to the ways and welded into a complete hull. Because no rivet holes are necessary, welding is stronger than riveting. Weight, which can be saved by using lighter plates and by eliminating rivets, increases the ship's carrying capacity. Members are welded in constructing large buildings, skyscrapers, bridges, and other engineering projects in place of riveting them. If you like outdoor work, this offers an interesting job in the welding field, as do many other types of job welding. Pipeline welding should also interest you. Welding crews travel across the country, welding lengths of pipe together. This work, too, is carefully inspected, and you will have to pass special welding tests before you can do pipeline welding, or weld any other high-pressure equipment, such as steam pipes or boilers. New applications of welding are continually being employed in many industries, and as a result, the welding field will probably continue to grow. For the welding operator who develops real skill, there are good opportunities.